second part of Year 13's extra follow-on chemistry with the acids and alkalis. Mixing unequally. Now, not necessarily obvious what that means. That means when one of the acid and the alkali is in excess, you can go on to calculate what the final pH would be. Straightforward process really. Calculate the moles of each one, look at the equation, work out which one's going to run out. The one that's not going to run out determines whether it's going to be an acid or an alkaline pH. Work out how many moles of that is in what volume, its concentration, do the pH calculation. Done. Could be an excess of acid, could be an excess of alkali. We will take you through what you do. It's not terribly complicated. So, we're going to do this only with strong acids and strong alkalis. I'll explain why, if I remember, at the end. We don't do this with weak acids. So let's go. So the strong acid, strong alkali, 100% ionisation like you were doing with the questions from last time. All we've got to do, have a question. Now I pre-prep some questions so we don't have to think we punch in a calculator. So we just need to write what we're doing on the board. So, first thing, 50 cubic centimetres of hydrochloric acid there we go. So 50 cubic centimetres of that, and we'll mix that with 60 cubic centimetres of .5 moles per cubic decimetre sodium hydroxide. So very straightforward, very common neutralisation. Now when you look at that, when I look at that, I can say that that's going to be the one in excess and that's going to run out. But I can then look at that and go, that's only because the concentrations and the volumes. But we can work out how much of each one. So if we look at the HCl and we look at the sodium hydroxide, we look at how many moles of each one there is, you know, volume over 1,000 times the concentration. HCl, or how many? 0.0375 it says there on my piece of paper. Is it moles? And the sodium hydroxide, 0.03. There we go. So, need the equation, but the equation between sodium hydroxide and HCl is a 1-to-1 ratio, so therefore quite straightforward, 1-to-1, HCl is in excess. The excess of hydrochloric acid, not supposed to write excess in an exam, bad, and is therefore 0.0375 minus 0.0300 equals magically 0.0075 moles of HCl. Total volume 110. 110.0 really, but so we got 0.0075 moles in 110. So you do have to go, each one's diluted each other. So the hydrochloric acid was diluted by 60 of that, and the 60 of that was diluted by the 50 of that. The excess of hydrochloric acid is then in 110. Work out the concentration. That's just like the reverse of what we did to work out how many moles. And it turns out that the concentration of HCl, which I'm not going to write down, because the concentration of HCl is exactly the same as the concentration of hydrogen ions, is when you calculate it by doing number of moles times 1,000 over the volume over 110 is 0.06818 moles per cubic decimetre. So all you do, there's your concentration of hydrogen ions, minus log, just like before. pH is 1.1, oh I've forgotten, hopeless, let me look, 1.17, there we go. So the pH is 1.17. Excess of hydrochloric acid, 110, work out the concentration, get the pH. pH of mixing those two together would be 1.17 because of the excess acid. We're going to take a little pause whilst I clear the board off and set up the next equation. Hello, welcome back. Right, time for excess of base. So, as a bass player, could never not have an excess of bass. Different bass. Right, so, I'm going to bring a second little idea into it as well. So, sulfuric acid and KOH. It's not 1 to 1. Need 2 KOHs for the sulfate. So goes on and makes potassium sulfate and water. But it's a 2 KOH 1 sulfuric. Now, need a question? Question. I'll set it out this way this time. And 50 cubic centimetres, 0.45 miles per cubic decimetre, and then the KOH 100 cm cubed, and concentration of 0.5 miles per cubic decimetre. Could have an extra 0 in there so we can do the accuracy, but I didn't remember. Now, when you do that, 50 over 1000 times 0.45 is 0.0225 moles, and the KOH 0.05 moles. Now, I've said that this is in excess, but the question is by how much. So you look at that, it would only, if you had that, it would need 0.025 moles of sulfuric. You haven't got 0.025 moles of sulfuric, you've only got 225, so you're going to run out of sulfuric acid. So if you do times, if you go, oh, that's the one that's going to run out, I need to double that, 0.0445 moles. So that's how much KOH will react with the amount of acid that we've got. I'm not doing it accurately with the number of zeros, of trailing zeros. But you do that and we get an excess of 0.005 moles. And it's in 150. So, work out the concentration of hydroxide ions. 0.005. I'm just checking I haven't done something silly. 0.005 times 1000 divided by 150. Concentration of OH, concentration of hydroxide rather, is 0.03333, endlessly 333 all the way to the end of the world. Right. That's obviously a concentration. So 0.03333, got to get the pH, so you've got to go through kW. So the question does have to be at a particular temperature, because I did say last time kW is temperature sensitive and it goes up a little bit with temperature, so we're going to specify 298, which means we can use the very straightforward kW of 1 times 10 to the minus 14. So when you do that and you use the kW from in the way we used it yesterday, you get an H plus concentration of I've done that without looking and got it right, that's good. Right, and so there's your H plus concentration because you do the kW divided by the OH concentration, and therefore with that the pH is 12.5 or 12.52 if you did it more accurately, and That's because slightly excess of KOH in the 150, and therefore its concentration turns into a pH of that. Now question 3 on the sheet from yesterday, or the day before, or whichever day you did it, depending on when you're looking, is about mixing things unequally. So you're ready, you're equipped with the skills to do that, and we're kind of almost there. I just said at the beginning, you don't do this question with weak acids. And the reason is that they don't behave quite the same. The reason they don't behave quite the same is that when you do a strong base and a weak acid, you end up with a whole new thing, and that is the next session we're going to have, called buffers. So that's why weak acids aren't in this unequal mixing, because we need to go on. There's a whole special way to do the various things to do with buffers, and that's our next time when we meet together. So right now you are ready to go for question 3. The answers are already attached to the show my homework thing that was set a couple of days back. So there we are, pretty short this time. Time to get going. Bye.